So question 3a, explain why PH3 can form a dative covalent bond with H plus but not PH2. So PH3 dative covalent bond with H plus and not PH2. Check the valence electron. When we have the valence electron, we can draw the Lewis structure. Before we draw the Lewis structure, we can calculate the total valence electron. You can see that PH3 have one lone pair and BH3 have no lone pair. So we can conclude that why the question said explain why PH3 can form a dative covalent bond with H plus but not BH3. So we can PH3 can form dative bond with H plus because the central atom of PH3, B, phosphorus, has one lone pair here. The central atom of PH3, B, does not has one lone pair. So thus H plus can form a bond with the one lone pair of B here, this bond, while H plus cannot bond with B due to the lack of lone pair. Because we know here it's already full, so this one doesn't have any lone pair, therefore we cannot H plus cannot bond with it. Question asks, write an equation to show the formation of P(F4 minus) from F minus ion molecule using Lewis symbol in the type of bond form. So to make it easier, we just write the equation first, then we write into the Lewis structure, Lewis symbol. So the equation, write the equation to show the formation, blah, 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 using Lewis symbol. So this is the Lewis symbol from this equation. So we have to write the equation first. Anyways, this one doesn't have any mark, but if you show this, it will make your life easier to make the Lewis symbol using the Lewis symbol. So we can see here PF3 plus F minus will bond PF4 minus. So fluorine ion will bond to the central atom of PF3. This arrow shows that fluorine ion bond with the boron using a dative bond. So the type of bond form is dative bond. To show that the type of bond form is dative bond, you must show this arrow, because the only bond, dative bond is the only bond that you have to show this arrow. So if you show this one is just covalent or ionic bond. So dative bond, you have to show this arrow. So yeah. Question C, fossil COCl2 is colorless, highly toxic gas employed against troop in World War I and used today as a key reactant in organic synthesis. 1. Draw a possible Lewis structure for phosphine. Then identify the most possible structure and explain. So first we have to draw all possible Lewis structure of COCl2 and most possible structure. So first we have to write the valence electron and then count the total valence electron before drawing the Lewis structure. So now we have the two structure of our possible Lewis structure. Now we have to know the most possible, we have to calculate the formal charge of each structure. The possible Lewis structure for COCl2 only have two structure, because first we have to know the rule that the rule is CON. If CON as the central atom, it must be octet number. So by following that rule, we know that structure 1 and structure 2 is the only Lewis structure for COCl2. For this one, for the structure, if you do the Lewis structures like this, even though this one, the total valence electron is 24, but it is not accepted because the central atom is gone. It is, and this is not the octet number. This one is just 222. This is just 6. So this one is not accepted. So see, for the structure of the Lewis structure for COCl2, it only have this one and this one. We have to octet the central atom, which is carbon. So to know this one, you can see that this one have 2Cl, 2 chlorine, which have different number of bond. This one have double bond and this one only have one single bond. So to differentiate, while calculating the formal charge, you have to write the Cl1 and Cl2. Yeah, Cl1 and Cl2. So when you calculate it, and then you have this one, 1, 2, 3, then only one have two zero formal charge. As we can see here, that structure 1 is the most plausible Lewis structure. Because to know the most plausible Lewis structure, um, it must have the more zero formal charge. And then when you are calculating the zero formal charge, you have to write the positive and negative sign like this. Positive 1 and negative 1. You cannot write 1, even though you know that 1 is positive. Even though you know that 1 is equal to positive 1, but you must show the positive sign. C2 determine the molecular shape and polarity of phosgene. The molecular shape is trigonal. So because from this one, we know the structure 1, right? So it's like trigonal. You know what I mean? Trigonal plana. Plana means plane, right? So trigonal in a plane. So the molecular shape of the COCl2 is trigonal planar. So now the polarity of phosgene. So to know the polarity of phosgene, we draw the molecular shape of the phosgene first. So here we know that COCl2 is a polar molecule because of they cannot cancel each other. So first, they are not the same element, therefore they cannot cancel each other. So first you have to write the COCl2 is a polar molecule. Oxygen and chlorine is more electronegative than carbon, so that all bonds are polar here. Polar. Bond dipoles arrange unsymmetrically. One go up and one go down. And then all bond dipoles cannot cancel each other. Because of this element is not the same. But if the element is the same, they can cancel each other. Thus the COCl2 is a polar molecule. It's not equal to 0. And that's all.